some demonstration code. First of all, you want to clear everything and then close all the previous figures. And then you want to clear this command line. Then what you want to do is you want to set up a variable, for example, x equals to, let's say, from 0 with 0.1 second interval until, say, 10 seconds. And because this is a matrix, let me just address this. And then let me just say that. So this is a matrix. The reason I'm putting a column here is to, they don't really show everything of x in the command line. For example, if I do x equals to 0, 0.01, that until 1. That basically shows that I'm going to go from 0 with a step size of 0.01 until it increased to 1.0. So if I don't put a semicolon here, then it's going to show all the x value here. It makes the screen messy. But instead, if we do this, you can see that it won't sit there. And then the x is actually in this memory. If you double click that, you can see that I actually assigned value from 0 with a step size of 0.01 until 1 to this x matrix. So once I have done that, you can see if I do CLC, it's going to clear everything. So that's why I usually would put CLC here just to make the command line cleared. So this is our time, basically. We can also change this to time. And then we want to plot it out. Our frequency equals to 60 Hertz. And then our voltage magnitude equals to, say, 120. And then we want to see if it's a sine wave, what it looks like. So voltage equals to voltage magnitude times sine omega. Omega, let's see, omega equals to 2 times pi. You can either say pi or you can put 3.14 there, but I usually use pi because it's more accurate. And then you can see that if I do omega equals to this, what will happen is it will just give me this value, okay? So pi basically is 3.1416. So that's omega, and then it's omega times time. And then suppose we have an initial angle, like say theta equals to 30 degrees. Remember, 30 degrees is a degree. We want it to be divided by 2 divided by pi. So actually, no, divided by 330 times 2 times pi. So this will actually change from degree to media. So we can say plus theta. That is our initial value. So once we have that, we can plot ELT, time, and voltage. Suppose you want this to be of a specific color, say red, and then with equals to, say, thicker, like 2. So let's see how it is. Let's run this code. Just say on desktop. Let's make it courses, and then ECE451. Let's go set up a new one. So I'll put all the demonstration code here. MATLAB demo. Let's say demo 1. Sign. Wait. Okay. So let's see how it goes. Change folder. You can see that I'm going to plot out a sine wave here. And then you'll see that if I put hold on here, then there's hold there. And let me comment it out, this one. So when I run it again, this curve will not disappear. So the reason I want to do that is want to see when we have different initial values for this theta, then what we'll get. So let's start from 0. Okay. I would change this to blue. Okay. So now I ran it again. You will see that there's a difference here. That means when I have, let's see, zoom in a little bit. You can use this zoom. Now you can see it more closely. You see that when I have a 0 here, because I use a sine, so I start from 0, and then this is nice sine wave. But if I have an initial angle, theta equals to 30 degree, then actually this is leading for 30 degree. So suppose we have a line here, you can see that I actually reach 0 here, 30 degree ahead of the blue line, okay? So if you want to see that, you actually can say, hey, I'm going to make it minus 30. Let's see what happened. Okay, I'm going to do that again. Oh, I forgot to change the value. Change this to green, okay? So now when we take a look at that, you see that if I put a minus, then that means I basically have a delay here. Let me just put one more thing here. Grid on. So I'm going to do that. Let's see. I have grid. So this is more clear because you can see that here, suppose I'm going here. You see that this guy reaches 0, and then the red line basically have a positive 30 degree, which is leading. And the green one is minus 30 degree, which is lagging, meaning the red one will go start from 0, rise up and goes down, and then blue one have a 30 degree lag, the red one, and this has a 30 degree lag of those. So by doing that, basically you can try different kind of things, just use this symbol code. For example, you know that we have a 120 degree lagging between different lines. So let's do another thing. You can see that if I'm just going to copy this, let me just clear these code. Let's just do this. Control. This is say 120, and then I plot it once. And then I'm going to do another thing. Just see. I'm going to do positive, and then plot it again. Let's say this is red, this is green, and then I'm going to do it again. So I'm going to make it 0. So let's say this is phase A, this is this A. Let's say we make it phase A. So this is comment. So phase A starts from 0. And then I plot this out. And then